All right, in this video, we're going to continue the equations that we were doing in the last video, the equations from section 6.6. So let's do one more log equation. Let's say we have log of 4 plus log of x minus 3 equals 2. All right, so this one is similar to the last one that we did. All right, we've got logs here that we're going to need to combine before we can do anything. And for this one, it looks like we're trying to get to log is equal to a number. So log is equal to a number. If you see a number by itself like that, you're going to want to try to get to log is equal to a number because there's the number's going to be there somewhere. There's no way to get rid of it. So if you get to log is equal to a number, you're looking at rule number 1. Log is equal to a number, and you're going to convert that to exponential. So that's what we're looking for here, is we're trying to get to log is equal to a number. All right, so we know that we need to combine the left-hand side. We've got log plus log, and we know that addition combines as multiplication. So we're going to get log of 4 times x minus 3 when we combine that. Okay, so addition combines as multiplication. So now we've got log is equal to a number. We can use rule number 1 and convert that to exponential. But in order to convert this exponential, we've got to know what the base of this logarithm is. So you have to remember that common log is base 10. When there's no base written here, you have to remember that it's implied to be a 10. Okay, so common log is base 10. So now that we remember that, we can convert it to exponential. The base is 10, the exponent is 2. So we've got 10 squared is equal to 4 times x minus 3. Okay, so we take log is equal to a number, we convert to exponential. So now we have something that we can solve. 10 squared is 100. We can multiply this out and get 4x minus 12. Trying to solve for x, so we add 12 to both sides. We get 112 is equal to 4x. Divide by 4 on both sides, and we get 28 is equal to x. All right, 28 is equal to x. Remember, you have to check that answer. Always check. So you come up here, this logarithm's always going to be okay. When we plug 28 in here, 28 minus 3 is 25. That's definitely positive, and there's no logarithm on that side. So we can go ahead and keep 28 equals x. All right, so we've done one of each of the logarithms. Let's go ahead and work on some exponential functions now. So let's say we have something like 2 to the x is equal to 7. Now, before when we looked at exponentials, we used property number 3 right here. And we said if the bases match, then the exponents must be the same. That's still true, and if you can get the bases to match, that is the fastest, easiest way to do it, most foolproof. You're not going to make any mistakes, and you don't need a calculator. So if you can get the bases to match, rule number 3 is still the way to go. But if we can't get the bases to match, then what do? Well, in this one, 2 and 7, we can't get those bases to match. We can't rewrite 7 with a base of 2, so we're going to have to do something else. And the thing to remember here is that you can take a logarithm on both sides. See property number 2 right here? We've used it, if the logs match, then what's on the inside has to be the same, but the other is true. If you have two things that are equal, their logarithms are equal also, which means you can take a log on both sides. So what log do we want to take? Well, let's do natural log, because then when we get our answers, we can put it in the calculator. You can take any log, but natural log is nice because we can use our calculators for it. So let's take a natural log on both sides. So we get natural log of 2 to the x equals natural log of 7. How does this help us? Well, remember rule number 6. Rule number 6 tells us that an exponent inside the logarithm is the same as a coefficient. That's going to get that x out of the exponent so we can actually get to it. So we get x ln 2 equals ln 7. And now ln 2 and ln 7 are just numbers. All we have to do is get x by itself. So we divide by natural log of 2 here. We divide by natural log of 2 here. And we get that x is equal to natural log of 7 over natural log of 2. Okay, so we take the natural log so we can bring that exponent down, and then when we get to our answer, we have something that we can put into any calculator. All right, so natural log of 7 over natural log of 2, that should be equal to 2.81. You should verify that on your calculator and make sure that you can get these decimals correct, because remember the exam is going to be mostly multiple choice. Right? So make sure that you can get natural log of 7 over natural log of 2, and that you can also get the decimal 2.81. All right, so let's come over, whoops. Let's erase this one and try another exponential equation. All right, let's try 3e to the 2x equals 5. 3e to the 2x is equal to 5. Okay, so we have another exponential equation. We've got e in here, and there's no way to match e unless you also have another e. So we're not going to be able to get this to match. So we're going to want to take a logarithm. But before we take a logarithm, we've got to make sure that this exponential is by itself. Remember, exponents only go with what they're next to unless there are parentheses telling you otherwise. So the exponent only goes with e. It does not go with the 3. The 3 is not part of that exponent. So what we need to do is we need to get the exponent by itself first. So let's divide by 3 on both sides. And we get e to the 2x is equal to 5/3. Now we've got the exponential by itself. We can't get the bases to match, so now we can take a natural log. So natural log of e to the 2x is equal to natural log of 5/3. And if you remember way back in section 6.4, we talked about natural log and e. Remember, they are inverses. Natural log is base e. Natural log and e will cancel each other out. So log base e and e, okay, same base. So on the left-hand side, we just get 2x. Natural log and e cancel each other out. So we get 2x is equal to natural log of 5/3. We need to get x by itself. So we're going to divide both sides by 2. And we get that x is equal to natural log of 5/3 over 2. Okay, now remember, when we have a logarithm, you cannot put numbers in there. So there's no way for me to put this 2 into the natural log. We don't want to do that. It's going to be natural log of 5/3 and then the whole thing over 2. When you put that in your calculator, let me find it, hold on. You should get 0.26, something like that when you round it. Okay, so when you put that in your calculator, you should get 0.26. Make sure that you have the parentheses around the whole 5/3. So 5 over 3 inside that parentheses and then over 2. All right, so we've got a couple exponential equations under our belt. Let's try one more. Let's say that we have 3 to the 2x is equal to 5 to the x plus 4. 3 to the 2x is equal to 5 to the x plus 4. All right, so again, we've got exponentials. Again, we cannot get the bases to match. There's no way to get 3 and 5 to match. So again, we're going to need to use our little trick of taking a natural log on each side. Okay, so we take a natural log on the left. We take a natural log on the right. And remember, we do that because now we can bring the exponents down. So these exponents are going to come down to the front. So I'm going to have 2x ln 3. And I'm going to have x plus 4 ln 5. Don't forget to put parentheses around that x plus 4. That does matter. All right, we can't really do anything on the left here. We're going to leave 2x ln 3 alone. On the right, we need to distribute this ln 5. So we're going to get x ln 5 plus 4 ln 5. All right, and now this one's a little bit different from the one before because we've got 2x terms. So we need to get these x terms on the same side. So I can't do anything inside the logarithm, but I can move the whole thing. So let's move this one, minus x ln 5. Let's move that over here. So we get 2x ln 3 minus x ln 5 equals 4 ln 5. All right, now this one's a little bit different from the other ones that we've done. You have to remember that natural log of 3 and natural log of 5 cannot be combined. It's like square root of 3 and square root of 5. You cannot put these together. So we cannot put these two terms on the left together in any way, but we still need to get x by itself. So the trick you have to remember here is that we factor the x out. Both terms have an x in them, so we factor the x out. So our first term becomes 2 ln 3. We take the x out, and our second one is ln 5. And that's still equal to 4 ln 5. All right, I'm running out of space here, so let me come over to the left with this. All right, so I'm going to just rewrite what we have right there. We've got x times 2 ln 3 minus ln 5 equals 4 ln 5. This is where we are so far. So we factor that x out. That's how you isolate the x when you can't combine terms. So now to get x by itself, we just divide by this it's just a number. It's big, but it's just a number. 2 ln 3 minus ln 5. I'm going to go ahead and leave that in parentheses because you're going to want to remember that when you get to your calculator anyway. Okay, so our final answer is 4 ln 5 over 2 ln 3 minus ln 5. Let me rewrite that a little bit better. 2 ln 3 minus ln 5. And again, when you put this in your calculator, you need to put parentheses around that whole denominator, otherwise it's not going to come out right. So that answer is the final answer. If you want to see if you can get the calculator answer for this, you should get, let me find it, it should come out to 10.95. 10.95, if I did that right. If you get a different answer, you let me know and we'll see what's going on. All right, but when I put that in, I got 10.95. All right, so that gives us one of each type of exponential now and one of each type of log. So you should be all set for the log and exponential equation section 6.6.